Hello everyone! Our topic for today is about motion graph and diagram. Directions. Study the picture and identify the motion illustrated. Choose your answer from the given options. What do you think is the answer in number 1? Is it linear motion, curvilinear motion, circular rotational motion? If your answer is linear motion, yes, you are correct. This is an example of linear motion. You can see the lines here. In number 2 example, what kind of motion is this? Is it linear motion, curvilinear motion, circular rotational motion? If your answer is curvilinear motion, yes, you are correct. This is an example of curvilinear motion. You can see the curve here. Another example is this. What kind of motion is this? Is it linear motion, curvilinear motion, circular rotational motion? If your answer is circular rotational motion, yes, you are correct. This is an example of circular rotational motion. You can see the circular rotational motion. Are you familiar with this? These are the graphs. What is a graph? Graphs are very useful means of presenting information and making it easily understood. It demonstrates trend, pattern, and relationship between sets of data. People find it easy to understand information through the use of graphs or charts. Graphs or charts are of different types: pie charts, pictographs, organizational charts, flow charts, cosmographs, bar and line graphs. Here are the types of graph. The first type of graph is pie graph. This is an example of pie graph. What is a pie graph? A pie graph shows values of variables and it is basically a circle divided into segments to show proportion. Another type of a graph is pictographs or pictograms. What is pictograph or pictograms? Pictograph or pictograms show data using pictures as symbols, just like this one. This is an example of pictographs or pictograms. This is an example of an organizational chart. What is an organizational chart? An organizational chart shows the overall structure of a workforce of a company. Another type of a graph is bar graph. What is a bar graph? A bar graph shows the comparison of data using rectangular bar. This is an example of bar graph. Another type of a graph is line graph. What is line graph? Line graph used to display the comparison between two variables which are plotted on the horizontal x and vertical y axis of a grid. It uses line to connect individual data points. The most popular type of graph because they are simple to create and easy to understand. This is an example of line graph. As what has stated earlier, bar graph and line graph are graphs that uses x and y axis to interpret the relationship of data. Bar graph with its x and y axis. For example, this one. Y-axis, y-axis, y-axis. Y-axis are vertical. And x-axis, x-axis, x-axis. X-axis are horizontal. The horizontal axis is called the x-axis. The x-axis usually represents measures of time, and the independent variable is plotted along this axis. The vertical axis is called y-axis. The y-axis usually represents percentage or measures of quantity, and dependent the variable is plotted in this axis. The x and y axis cross or meet or intersect at a point which is called origin. The coordinates are 0, 0. Here are the difference between x-axis and y-axis. X-axis, horizontal axis, represents measure of time. Independent variable is plotted in this axis. Y-axis, vertical axis, represents percentage or measures quantity. Dependent variable is plotted in this axis. Independent variable. What is independent variable? It is a variable that stands alone and isn't changed by the other variables you are trying to measure. Dependent variable. What is dependent variable? Dependent variable is the outcome that you measure. This is an example of x-axis. It is horizontal. And this is an example of y-axis. It is vertical. These are the examples of x-axis, y-axis, and origin. This is the x-axis. As I told you, x-axis is horizontal. And this is y-axis. As I told you, a y-axis is vertical. And this is the origin, the color green. Let's see. Let's meet graphic motion. Now let's go to distance time graph. Distance time graph. D stands for distance and T stands for time. Time is for x-axis and distance is for y-axis. Time is plotted on the x-axis. The farther to the right on the axis, the longer the time from the start. Distance is plotted on the y-axis. The higher at the graph, the further from the start. One way of describing motion is by plotting distance against time in a Cartesian plane. Like in our mathematics class, this presentation will make use of x and y-axis. Distance time graph. Distance time graph. As I told you, D stands for distance and T stands for time. Object is at rest. Time is for x-axis and distance is for y-axis. An object is not moving when a horizontal line is shown on a distance time graph. In this case, time is increasing to the right, but the distance remains the same. The object is not moving, hence the object is at rest. An object is moving at a constant speed when the distance covered increases constantly with time. Constant speed is shown by a straight line on a graph. Suppose we have two moving objects. Both of the line in the graph shows that each object moved the same distance, but the steeper dashed line got there before the other one. The steeper dashed line indicates that the object has moved a greater distance at a given time. In other words, it has higher speed than the object which is represented by the solid line. Both lines are straight, so both speed are constant. Below is a graph that shows acceleration. It looks different from those that show constant speed. The line on this graph is curving upward. This shows an increase in speed since the line is getting steeper. In other words, the object is accelerating. Speed, velocity, and time graph. V stands for velocity and T stands for time. Another type of motion graph is the velocity time graph. The velocity of the object is plotted against time, although it looks much like distance time graphs. The slope of the graph describes acceleration of the object. Object moving at constant speed. The figure shows an object moving at a constant speed. A straight horizontal line means that the speed is constant. It is not changing over time. A straight line in this case does not mean that the object is at rest. Remember, this is a VT or velocity and time graph. Object is accelerating or speeding up. The moving object is said to be accelerating when its speed is increasing as shown in the graph. Object is decelerating or slowing down. Figure 6 shows that the moving object is decreasing its speed or slowing down. Thus, the moving object is decelerating. Now, let us study the use of diagram in describing motion. Another method of describing motion is through the use of diagram. A ticker tape diagram is an example of motion diagram. This is sometimes called as dot diagram, which makes use of a stationary ticker that marks the tape of a regular time intervals. A moving object drags a tape past the ticker, and a trail of mark is left on the tape. For an object moving with uniform velocity, the marks are spaced uniformly on the tape. A dot diagram reveals if the object is moving with a constant velocity or accelerating. A changing distance between dots indicates a changing velocity and thus accelerating. A constant distance between dots represents a constant velocity and therefore no acceleration. Dot diagram for objects moving with a constant velocity and with accelerated motion are shown below. Constant speed. Accelerating. Lots of acceleration. The trail of dots is a representation of the object's motion. The distance between the dots represents the speed of object at a certain time interval. Dot diagram A. A large distance between the dots means that the object was moving fast during a time interval. Dot diagram B. The small distance between the dots means that the object was moving slow during a time travel. Equals distance means constant speed, no acceleration. The speed is increasing. The speed of the object is increasing because the distance between the dots is getting larger. The speed is decreasing. The speed of the object is decreasing because the distance between the dots is getting smaller. Activity time. Jose owns a new car. Analyze the three traces of Jose's adventure as shown below. Assume Jose is traveling from left to right. Describe his car's motion characteristics during each section of the diagram. A. What happens to the car's speed in section A? B. Infer the car's motion at section B. C. Describe the car's motion in section C. A. What happens to the car's speed in section A? The answer is the car's speed is decreasing. Letter B. Infer the car's motion at section B. The car's speed is very slow. Letter C. Describe the car's motion in section C. The car's speed is increasing. Describe the car's motion for sections. A. The car has a constant speed. B. The car's speed is decreasing. And that would be all about the representation of motion. Thank you for watching. Until next time, goodbye.